Hello everyone and welcome to another Würth Elektronik ISOS webinar. My name is Markus Eberle and I will moderate this webinar today. We are very pleased that you took the time to participate in our webinar. The topic of today's webinar is Bluetooth Low Energy versus 2.4 GHz Proprietary Wireless, the right connectivity for your industrial application. Our speaker today is Aditya Madanahalli, who is working as software engineer in the field of wireless connectivity and sensors at WE ISOS. He will hold today's webinar and also answer your questions. As we also take all possible steps against the coronavirus, we are unfortunately not sitting in the same rooms today, but are holding the webinar out of the home office. #stay at home. In case of technical problems, please take this into account. We will do our best to make a smooth process possible. Before we start the webinar, I would like to point out one thing. You will be muted during the webinar today. This means that you cannot ask us questions via microphone during the webinar. Nevertheless, you have the opportunity to ask us questions during the webinar at any time via the chat function. You will find the chat function in the webinar control panel. The webinar will be about 30 minutes long. The chat questions will then be answered in a question-answer session following the webinar. There are 10 to 15 minutes in addition scheduled for this. If we are unable to answer all your questions within this time, we will answer them via email after the webinar. If you still have any other questions left after the webinar, just email us at isos-webinar@we-online.com. We will try to answer all questions promptly. At the end of the webinar, you will be asked to participate in a feedback survey. We would be pleased if you take the time to fill out the survey and help us to improve our webinars. You will also receive the link to the presentation as well as to the recording of the webinar in the next few weeks, as we need a longer processing time due to the extended webinar offer. So now I will hand over to our speaker, Aditya, and I wish you an exciting webinar.
Thank you, Marcus. Warm welcome from my side to the webinar today. I see a lot of you guys have registered from all over the world. It is really humbling to see so many listeners today for this webinar. The topic being Bluetooth Low Energy versus 2.4 GHz Proprietary Wireless for your industrial application. Hope you're all staying home, staying healthy. Staying at home has done a couple of things here. It has helped us, quieten our life and think about improving things. Talking of improving things, we can talk about improving our industrial devices. One such improvement could be enabling your industrial device with a wireless connectivity solution, which is going to be the topic for today's webinar. A brief overview of what I would be presenting today. I will begin, as just said, about wireless connectivity in general for industrial Internet of Things applications. What are the most important factors to be considered when designing a wireless connectivity solution with the help of a typical industrial application example? Then we go to the core of the topic today, giving you a brief overview of proprietary radio protocol and as well as the Bluetooth and Bluetooth Low Energy protocols. We compare these two standards and also stay tuned for a short presentation of the two new products in our portfolio from Würth Elektronik ISOS. So let's get things started. Industrial Internet of Things. Just sit back and imagine what comes to your mind when you think about industrial Internet of Things or Internet of Things in general. It's hard to imagine, right? I mean, there is not one specific definition, so to say, about Internet of Things. So it can be sensors, wireless connectivity, gateways, cloud, a lot of protocols, and then you have applications like asset tracking, intelligent machine interface, virtual machines, enhancing safety, industrial digitalization, industry 4.0, and so on. Yeah, I mean, I call, or for me, industrial internet of things is an umbrella term which encompasses all these factors. In the end, any industrial IoT application brings data from the field to the cloud, and processing of this data somehow enables the user to gain some kind of value added uh, services. For example, predictive maintenance, enhanced safety, process optimization, and so on and so forth. But the heart that of all these systems, or the enabling technology which allows these applications to utilize their maximum, is wireless connectivity. So wireless connectivity is at the heart of the industrial internet of things. In today's for the sake of simplicity and today's discussion, let us consider the most often used application in an industrial setup: remote monitoring and control. When you think of remote monitoring and control, for example, you can see here, as you see in the picture here, there is a robotic arm that is being controlled remotely, and is more or less fully autonomous, but there has to be some kind of maintenance that needs to be done. The system needs to be monitored in order to prevent outages. So in this kind of a system, let us imagine a big industrial hall, say a couple of hundreds of meters large, and the devices that are in the hall have to communicate with the central device or with each other. Often in these kind of situations, it is clear that uh, the devices that are mounted on such places have to be wireless. You can't draw cables on a moving robotic arm like this. So it is very, very clear that wireless connectivity is at the heart of such an application. So what are the requirements on the wireless connectivity uh, technology that can support these kind of applications? First, the range. As you can see, the machines are inside a hall of an industrial production area, so a couple of hundreds of meters. As often is the case, these devices are battery operated. So you install the device and forget it for a few years, or for 5 to 10 years in the best case. The device work completely autonomously without any supervision. The most important thing is to consider is security. So the data is really sensitive, hence it has to be securely transmitted from one device to the other. So just keep this specific remote monitoring and control application in mind. This will be visited often in sites. Yeah, moving on. What are the factors that needs to be considered when we have to design such a wireless connectivity application? The first question that comes to my mind is the frequency of operation. Yeah. Um, there are a lot of options ranging from the sub gigahertz up to the 2.4 gigahertz and 5 gigahertz band and so on. But 2.4 gigahertz is the most frequently used for such kind of applications. The most important factor to consider here is the global availability. The 2.4 gigahertz frequency ISM band is globally available. Hence, you can design a device once and can be deployed anywhere in the world. On the other hand, the disadvantage here being that a lot of devices, including the Wi-Fi routers and devices, operate in the 2.4 gigahertz band. It is a crowded spectrum, and in case of a industrial environment, we have to ensure that the wireless link is robust. More on that a little later in my presentation. Few other factors to consider is the radio range and data throughput. So the wireless connectivity solution has to support the range intended for the application, and also should be able to provide the data throughput necessary for the application. The energy budget, as I said, most of the devices are battery operated, and it is very important to consider energy calculations right from the design phase, which means that low power design has to be incorporated in hardware, software, high level protocol, and to the end device. So this is very, very important to consider. A similar factor is security. Security by design is a must for the modern day applications. Then you have the choice of wireless protocols. There are a number of technologies, Wi-Fi, Bluetooth, Thread, Zigbee, to name a few here. So a choice has to be made on which technology is suitable for our application. A very practical consideration which is often neglected is the regulatory compliance. It is very important to know, although we are operating in a license-free brand, it doesn't mean that we don't need any regulations. There are regional regulatory norms that has to be satisfied by any device that is transmitting or receiving radio waves. For Europe, it is Radio Equipment Directive, FCC, IC is for then the North American continent, and so on. So these things have to be kept in mind while designing a wireless connectivity solution, among other things. Yeah. Now coming to the overview of radio standards. So we have a lot of standards, and here is a small visualization of where these standards stack up in terms of range and data rate. For our application, we are dealing in this region. I hope you can see my pointer in this region where we have low range, low to medium range, but really low data rate applications, which in turn means that these are low power applications. So let us say Bluetooth Low Energy, Proprietary, Thread, Zigbee, and so on. These are the protocols which can be considered for our remote control application, which I presented a few slides ago. Now that we have the radio technology, how does designing in such a radio module into an application look like? Well, it can be really simple if you use one of the radio modules like these. So this is one of our newest radio modules. More on that a little later. But using such a module like this, which implements the network, data link, and physical layers of the ISO OSI 7-layer model, if you see here, um, prevents a lot of possible errors and ensures that you get your product to the market in time. The factors like onboard antenna, easy to solder on to a design, makes the RF development of older days really outdated. So it is really smart to use such a module and build it to your application and be sure everything works out of the box. Now that we have narrowed down our wireless connectivity options to Bluetooth and proprietary, I would like to present a few standard features of proprietary radio modules. So what is proprietary radio? Um, Typically, there is no specific definition for proprietary because proprietary just means that not conforming to any standard. What does this mean? What are the advantages and disadvantages? The disadvantage is clearly that you will not be able to build a network with different devices that are interoperable with each other from different manufacturers. So they have to all use the same radio technology to be able to talk with each other. So this is what a standard does. But being proprietary, it is easy to build a network with isolated application. But the most important factor to be considered here is, since this proprietary radio modules do not comply to any standard, they need not be designed for a generic application. For example, let's say Wi-Fi technology is a standard. It has to support a laptop, I don't know, a smart light control system. It has to support a smart fridge, a smart phone, and so on. So a single standard has to support all these different devices with different applications. On the other hand, a proprietary radio can be optimized to operate in a specific region, which means that it can be optimized to provide a specific functionality like high range, higher throughput, very optimal battery performance. So these are the advantages that you can achieve with proprietary radio. There are a lot of proprietary radio protocols available in the market, but today we're going to talk about the WE ProWare. The WE ProWare is the proprietary radio protocols from Würth Elektronik. as I was talking in my previous slide, a few things about the flexibility or the optimization in performance. Let's talk about the physical layer and the 2.4 gigahertz module from Würth Elektronik, the Thyone-I. So this offers the choice of, I mean, here you can see that there is something called the radio profile. The radio profile determines the characteristic of the radio module um, in the physical layer. So there are 4 different profiles available. So you can choose a long range mode with lower throughput, or really a very high throughput mode which has limited range. On the other hand, if you are stuck if you are going for a standard protocol, let's say a standard based on IEEE 802.15.4, for example Zigbee uses this standard, you're basically stuck with the single RF profile, which is good for certain applications but not suitable for everything. So, and of course you can configure the transmit power, which makes it optimal, or which makes it very useful to optimize your battery consumption and energy performance. Moving on to the data link and the network layers here. The WE ProWare offers in the MAC layer the clear channel assessment, which is often referred to as listen before talk. So this is really important in the 2.4 gigahertz spectrum, because the spectrum is really crowded. You have a WLAN router that is transmitting, you have other BLE devices. So it is always important to implement CCA in order to provide a robust communication link. Additionally, security, as I said earlier, the module offers 128-bit AES and end-to-end encryption. At the network layer, you have 4-byte addressing, which can ensure unicast, multicast, and broadcast capabilities, and acknowledgement and retry mechanism are enabled by default. So these add to the robustness of the system. Mesh is, in the modern day, has become a really important functionality. Mesh networking enables the user to extend the range of the network, and provides additional possibilities like um, sending the same packet through the network over multiple links, and thereby creating a robust network. The WE ProWare out of the box offers flooding mesh functionality without additional provisioning. Flooding mesh is a very simple concept. Each module itself can be configured as a repeater, and once a module is configured as repeater, it forwards all the packets that it receives, other than the packets that is addressed to itself. So you can build a mesh functionality without having to worry about large routing tables and optimization and so on. Moving on, we have the next contender for our remote control application, the Bluetooth technology. Before I move on, I would again like to remind you guys, if you have any questions, please do not hesitate to ask it through the chat tool. We'll try our best to answer all your questions in time. Moving on, Bluetooth, I think all of us in the modern day have heard about Bluetooth. It is all pervasive. You have it on your cars and mobile phones. We often use Bluetooth enabled earphones, headphones, headsets, you name it. Bluetooth is there everywhere. So the origin of Bluetooth was from the special interest group, the SIG, Bluetooth SIG. It was done in 1998, and the intention was to connect peripheral devices to PCs, basically. So the intention here is to have a steady stream of data flowing wirelessly from a device which acts as a slave to a master. A little bit on the evolution of Bluetooth in the slide. So Bluetooth, uh, there are 2 variants in this case. The Bluetooth Classic, which is what was for PC connectivity, was developed. That version 3.0 was developed until 2009, and it offered features like serial port profile, and was also suitable for audio transmission. What was lacking in this Bluetooth Classic standard was the optimization for battery operated devices. So this with the growth of Internet of Things, with a lot of battery operated devices in store, the Bluetooth special interest group had to evolve their standard, and the result of it was version 4.0, which came out in 2010, and which is still under development, and it is termed as Bluetooth Low Energy. So the focus of Bluetooth Low Energy is then to offer a robust, secure, end-to-end wireless connectivity solution for low power devices, for battery power devices. And a recent development with Bluetooth has been the Bluetooth mesh. It itself is listed as a variant, although it is a standard on its own. So more on this a little bit later. Let's concentrate on Bluetooth Low Energy, because this is the real interesting thing for our remote control and monitoring industrial application. So Bluetooth Low Energy, as you already know, works in the 2.4 gigahertz band. It has it consists of 40 channels of 2 megahertz each. On the radio physical layer, you have options to select between 1 megahertz, 1 megabit per second data rate, and in the modern standards, a high throughput mode of 2 megabit per second, or a long range coded low energy mode of 125 kilobit per second. You have 3 advertising channels and 37 channels reserved for data communication. With Bluetooth, the communication is made robust using frequency hopping spread spectrum technology and TDMA, that is time division multiple access, helps in 2 fronts. One is makes the communication synchronous, and second also enables a lot of power saving, which I will explain in short while. As you can see, the difference here to the Bluetooth Classic is that in Bluetooth Low Energy, you have something like a duty cycle formation here. So there is a connection interval, which can be from 8 milliseconds to 10 seconds. It is usually configurable. So the device transmits data at the beginning of the connection interval and then goes into sleep. So the idea is to transmit as much data as possible, as fast as possible, and then save energy by going to sleep. These are the optimization which results in really very good energy performance of a Bluetooth Low Energy enabled system. A little bit on Bluetooth roles. You have the peripheral role, central role. These are the 2 primary roles of a Bluetooth connection. The peripheral is a device that offers certain services. For example, a loudspeaker, a Bluetooth speaker is a peripheral device. On the other hand, a mobile phone or a smartphone which connects to your Bluetooth speaker is a central device. So usually the central device initiates the connection, the peripheral device connects, and once the connection is done, a secure data transmission is possible. The standard also enables broadcasting beacons, periodic beacons, which can be interesting for some applications. On the other hand, the observer is the role where you can receive these beacons and uh, and have certain applications based on just receiving the beacons. This is typically used in smartphones these days. It's important to know these Bluetooth low energy states. Maybe we spoke about the advertising channels before. The peripherals advertise their services on the advertising channel. Usually the central device is scanning and looking for these advertising packets, and once it receives an advertising packet, it can initiate a communication. On initiating the communication, the key exchanges happen typically to establish a secure link, and once the connection is established, an authenticated and an encrypted link exists between the central and the peripheral. It is really important to keep these things in mind, because as we enter into the next stage of the presentation, where we compare the 2, Bluetooth Low Energy and the proprietary radio, these mechanisms play a really important role. So you might be thinking now, okay, we have a remote control application, we have defined the specification, and we have looked into the 2 contenders for the application, Bluetooth Low Energy and proprietary radio. What connectivity option should I choose? Glad you asked. So here is a table which summarizes the difference between the two. The most important thing to note here is that Bluetooth Low Energy is a connection setup based protocol, which means that there has to be a connection setup between central and the peripheral, which needs time and energy. So this is a really important factor. On the other hand, on the proprietary channel, you can send the data as and when it is available. Authentication is supported out of the box, which is not the case in proprietary, but there are certain mechanisms which can be implemented in the application level to enable authentication. Throughput, as you can see, there are no restrictions on connection intervals or such in case of proprietary, which makes it possible to send as much as data as possible, as physically possible. On the other hand, due to TDMA, you can see the power consumption is more optimized in case of Bluetooth Low Energy. Mesh is not supported under Bluetooth Low Energy, and on the other hand, on the proprietary, you have the option to use flooding mesh, at least from the using the WE ProWare. Another really important factor you need to consider is there is a certain cost for using Bluetooth Low Energy. Each device family that uses Bluetooth Low Energy has to be has to be listed under the Bluetooth Special Interest Group. So you have to consider a cost of around 8,000 euros one time or $8,000 one time in order to be able to use such a device in the field, which is of course not relevant in case of proprietary communication protocol. I have put a couple of slides here together to show you the most important differences when it comes to data transmission. Here you can see the data transmission sequence in case of a Bluetooth Low Energy on the top here, and the similar data packets when you transmit over a proprietary radio protocol. The most important factor here is that you have to set up a connection before you can transmit any data and close the connection on transmitting the data. So you have a host microcontroller which initiates a communication. And typically setting up a connection takes place anywhere between around 20 connection intervals, which is typically around 1,000 milliseconds. And a disconnection takes around 100 milliseconds. So there is already an overhead of typically of around 1,100 to 1,200 milliseconds before you can even start transmitting the data. This can be really critical. Let's say if you are transmitting data packets of like 250 bytes, but you have to set up these connections, and in order to save energy, you have to switch off the radio module after disconnecting. So this is really the most important and deciding factor when you choose wireless connectivity solution. Now let us concentrate on the data transmission itself. As we saw in the comparison table, the throughput of a proprietary device is higher than that of a Bluetooth device. Why does this happen? This is because you have here on the Bluetooth side, on the top here, the restriction that you can transmit just one packet typically in a connection interval. On the other hand, there are no such restrictions here. You can transmit as and when the data is available, and after a short processing time, the packet is sent over the radio. So keeping these things in mind, now let us come back to our industrial application, remote control application. Sorry to disappoint you. There is no one-stop solution for all the requirements, which means typically you choose the wireless connectivity solution based on the demands of your application. Let's say you have an application where you are transmitting from this robotic arm to a central device here. You don't have too much data rate requirements, which means you have smaller sensor data packets. You need a requirement to build a mesh network, which means the right choice for your system is a proprietary wireless communication standard. On the other hand, you need to be compatible or interconnectable with standard control devices, for example, like a smartphone or a PC or a tablet, which is Bluetooth enabled, and where the application requires advanced authentication or data encryption, then the choice for you is a Bluetooth enabled device, Bluetooth Low Energy enabled device. So as I said, there is no one-stop solution for all these things. But irrespective of whether you choose proprietary or the standard Bluetooth low energy, we have a single hardware platform which can cover both of these technologies. Let me interest you by introducing Thyone-I, the 2.4 GHz proprietary radio module, which comes in this attractive yet really small package of 12 by 8 millimeters. It's a nano SIM card size. You have an antenna built on board. I mean, this is the size compared to a €1 coin. So you can see it's really tiny. It is really flexible in terms of physical layer with 4 different radio profiles, supports flooding mesh. Most attractive probably for some kind of application would be a remote GPIO control. As you can see, the Thyone-I module has certain pins here. Of course, you have the standard UART interface and the antenna pins, but there are certain GPIO pins which can be configured using the radio interface. This is really interesting for some kind of remote control applications. Like I said, the module comes typically with a standard UART interface and a transparent UART interface, which is interesting if you have a device which is already using some kind of RS-232 or RS-485 serial communication. This Thyone-I can be a drag and drop replacement for your wired connection. So keep this in mind. This is really interesting. Not to forget, all our modules, including the Thyone-I, is pre-certified to be operated in Europe, US, Canada, and Japan. Further certifications can be obtained for operation anywhere in the world. Now the Bluetooth variant, the Proteus-III. Other than having the same physical size and the features with respect to smart antenna selection and this hand solderable pins, the Proteus-III offers a complete Bluetooth stack on board. So you don't need to have some kind of Bluetooth stack running on your host microcontroller. All you need to do is implement the command interface and interface it with the UART, and you're good to go. Most important thing to also to remember here is Proteus-III supports both central as well as the peripheral role. So it is really interesting for industrial applications where you can switch between different modes and really build a complex product using the Proteus-III. Moving on, now you have such a module. How do I design in such module into any industrial application? So you have the typical host microcontroller, which provides the standard UART interface. All our modules support UART as the primary interface. All you need to do is 4 steps. Provide the module with power supply, connect the UART, and connect the antenna in most cases, which involves just having a short circuit between 2 pins and the reset pin in order to be able to reset the module, and you're good to go. Additionally, there are other options which can be used. I wouldn't go into details of this. I think we have a really good set of documentation available, which can, and we are always happy to guide you through such a design in process. So how does this design in look on the software side, on the firmware side? So you have this host microcontroller application running here. All you have to do is use the wireless connectivity SDK, which is written in pure C. So it can be typically ported to any microcontroller. It can be 8-bit, ARM Cortex M4, M0, PIC microcontroller, doesn't matter. It's pure C, so it can be ported into any microcontroller. The SDK offers APIs styled command interface, so you can just send a command, for example, transmit a message. The SDK, on the other hand, communicates with the module in the language which the module understands and returns a confirm message once the data is transmitted out. On the receiver side, the data is of course received, and you get an indication in terms of a callback with the message that has been transmitted. So step 1, integrate hardware. Step 2, use the wireless connectivity SDK to get going. Step 3, well, there is no step 3. You're done basically. this brings me to the end of this presentation. I thank you all for being patient with me and listening to this presentation, to the webinar till now. I think we are ready to answer a few questions. I will hand over to Marcus in a while.
So, yeah, thank you,
Yep.
Aditya, for this interesting and great webinar. As you said, now we would like to turn our attention to your questions, and we wait a little until some questions have come in. Yeah, we have scheduled 10 to 15 minutes for this time, and we will take that time. So we will have a look. Okay, Aditya, we have the first question here. What does the GPIO remote control do?
Yeah, really interesting option. So as I told you in the previous, let me go back to my slides here. I think it's easier to show it using the slides. So this is, for example, a module. Okay, this just to be clear right out of the box, the remote GPIO functionality is also supported on Proteus-III as well as Thyone-I. So you have certain GPIO pins on the radio module itself, and these pins can be configured either as digital input or output. So let's say you have a small switch to operate through a relay. So and you need to you need to turn the switch on and off. So you can connect the module to your device and connect the GPIO to the switch. And for example, on the Proteus-III, you can connect to a smartphone and switch the light on and off directly through to the pin without actually even talking to the host microcontroller. So this is the really a big advantage using the remote GPIO control feature.
Okay, thank you, Aditya, for this explanation. I saw just the next question. Aditya, what about the certifications? So I think it's about, do the two modules have
Yes.
certifications already?
Yes, there are a few important points to be noted here. There are two important things. First one is the regulatory compliance. So you have RED for Europe, FCC for the United States, Industry Canada, RIP for Japan, and so on. These are the regulatory compliance certifications. Yes, all of our modules are pre-certified according to these standards, but it is really important to note that the device has to, the end device, which designs in our modules have to be also certified according to the standards, um, according to the standards and according to the regions where the end device will be deployed. Yes, the certification costs will be much less when using a pre-certified module. There has to be some delta tests that needs to be done, but you save a lot of time and money when using a pre-certified module. The second type of certification, or this I would call it as a listing, this is very specific to Bluetooth Low Energy modules. Uh, any Bluetooth device that is operational has to be listed uh, in the according to the special interest group, Bluetooth special interest group. Our module is already listed as as a radio module providing Bluetooth Low Energy technology under the Bluetooth SIG group, but uh, any end device that builds in this has to be also in the end listed under Bluetooth SIG. For this, it's really easy. You don't have to do any tests. It is more or less paperwork. So you get the declaration ID for a Bluetooth SIG from us and say we have built in this module into a device, and pay a one-time fees for a product line for Bluetooth SIG, and you're done. So basically the time involved and the effort involved in going through the Bluetooth qualification, Bluetooth testing, and um, this is really a lot of time. Bluetooth qualification and Bluetooth listing is then made really easy when you use a module that is pre-certified.
Okay. So there are a lot of advantages. So Aditya, the next question is, what is an SDK?
So SDK, the software development kit. So it's typical that, I don't know, from the days when we had some kind of radio transceivers, where you had an SPI interface and you had a set of, I don't know, depending on the complexity of the module, like 300, 400 registers, which had to be set to a specific value in order to get your radio module going. Yeah, those days are gone. So all we have to do with the help of the software development kit from WE is that you get a well-documented C library with yeah, obviously understandable functions that says transmit data, set radio channel, set transmit power, and so on. So you use these functions and switch the module into the mode that it wants to be without worrying about all the registers and all the things. So it is that you get a module as a black box and use the SDK and the APIs provided by the SDK to
Mhm.
get going and get going out of the box as soon as possible.
Okay, so now we will have a look at the other questions. Aditya, I just saw the next question. What is what is the output power of with Bluetooth module? So I think it's about the Proteus-III.
Yeah, the Proteus-III, it has the peak transmit power 4 dBm, and also it is the transmit power is of course configurable. Yeah.
Okay. So short question, short answer.
Yep.
The next question is, what is the range of this module? I don't know what module is meant. Do you know the range for both modules?
Yes, for sure. Let me go back to the graph here. Yeah. So the range, as I explained earlier, is there is always a compromise between throughput and range. So it depends on the radio profile chosen. So you have for the 125 kilobit profile, you have a line of sight range of around 750 meters. So this is considering the two-way reflection model with antenna placed at a height of 2 meters above the ground. So this is about the range we get. Although to be frank with you, we have done some kind of measurements where we could measure up more than 750 meters. So, but this is the range of both the modules. Let's say maximum range that can be achievable by both the modules. An interesting fact here, interesting hint, is that the Proteus-III module also supports connection in the long range mode, which is not typically supported by all, uh, which is not a must in the standard, and it is not typically supported by all the devices. So you can still initiate a connection when you are, let's say, more than 700 meters apart from the initiating device. Yeah.
Okay, crazy. I think that's a lot when you are looking at Bluetooth and like Bluetooth devices, like you know that.
Yes. Yes. Mhm.
Um, Aditya, the next question. When we design a system by using the Bluetooth module, do we need to pay additional cost for Bluetooth SIG apart from buying the module?
Yes, the module itself module itself is SIG listed, but that doesn't mean that the end product is somehow automatically listed. This is some kind of a licensing cost that we have to pay for the Bluetooth SIG, which is around $8,000 once per product type. So
Mhm.
if you have a product series with using the same radio module, for example, you pay the fees once. And like I said, getting the product SIG listed is really some paperwork without any other extra
Mhm.
testing effort and so on. Yeah.
Okay, thank you. Just now looking at the next question. Um, the next question I see in proprietary radio, actually, how the connection is being established?
The proprietary radio doesn't require any kind of connection because it is a connectionless system. So you can create a network using the 4-byte addressing and you can address to specific modules. So there is no need of any kind of connection setup. So it is connectionless. So whenever there is some data to be sent, you can either send it to a specific address or a group of devices or to all the devices in the vicinity. So it is very simple there, and there is no connection establishment necessary. On the advantage here is that you don't have you can save the time of connection setup and disconnection and so on. On the other hand, the device that is addressed has to be in the receiving mode when the data packet comes in. Yeah.
Okay. So now I think I see the next question. Aditya, what is the difference between NFC and proprietary radio?
NFC is again a standard radio, which has certain technology protocol defined, and proprietary radio is basically not conforming to any specific standard. So this is our own development. So to say, the WE ProWare is a protocol stack which defines the physical data link and network layer of a communication system that has been in existence for the last 20 years. So this is a completely different protocol stack.
Okay. So now we will have a look at the other questions. I would like to mention that if any question is open yet, we will answer them via email afterwards. So Aditya, the next question. How in the end product can we change the mode and power levels for the FCC certification of the end product?
Yes, the module can be configured to transmit for at a specific level. Yes, that is possible.
Okay. So we are looking for the next question. Aditya, I see the next question. At Bluetooth Low Energy, it says mesh is not supported, but there is a Bluetooth mesh. What's the difference to, and also what is the difference to the proprietary mesh?
Okay, the concept of mesh, I mean, this is really interesting because the Bluetooth-Ill already markets that it has a complete solution of Bluetooth mesh. But the most important point to be noted is that Bluetooth mesh is not the same as Bluetooth low energy, which means that Bluetooth low energy optimizations for low power is not really completely active in Bluetooth mesh. All that is common between Bluetooth low energy and mesh is the physical layer of both these technologies are the same.
Mhm.
Now to the second part of your question, the Bluetooth mesh and proprietary mesh. I mean, there is a significant difference because our proprietary mesh is a flooding mesh, and Bluetooth SIG calls its mesh network as a controlled mesh or a directed mesh network or a directed flooding mesh network. So it is a controlled flooding mechanism. But it is very important to note that there are several roles and it is more complex to build a mesh network. And you need, for example, once deployed, the nodes need to be provisioned into its roles. There is something called a friend node, a high power node, a low power node, a sleepy node, and so on. So there is certain provisioning that is necessary. So once the devices are installed, a person has to physically go and configure each device using, for example, a smartphone, and then set up a mesh network. In
Oh,
comparison,
mhm.
the flooding mesh for the proprietary protocol, I mean, it's you just configure the modules in repeater mode and they work out of the box. No need of a big configuration necessary.
Okay. Aditya, thank you for the explanation. And now we are finished with our webinar. If there are any questions left, we will answer them via email afterwards. So thank you for your attention, and I hope you enjoyed our webinar. Also, again, many thanks to you, Aditya, for this great and interesting webinar. I hope you will hear us at our next webinar, and I wish you a good day. Goodbye.